let's go over 5.3 today. First things first, today we are talking about proving congruent triangles or proving triangles congruent. First thing we want to talk about is the included angle. And that is the included angle, which is the angle formed when the shared side of a triangle. So if I were to draw a triangle, so here is an example. If I were to draw a triangle here, and let's highlight two of the sides meeting together, the angle that the two sides make that meet together, this angle right here, is considered the included angle. However, these are non-examples, so these are what they aren't. So if I were to draw two other different triangles and highlight the same sides here, the other angles that are not created by those two sides, so this side angle and this angle, are not the included angle. So the included angle has to be between the two sides. And this comes to our next portion of the side angle side or SAS theorem, which basically says if two sides and the included angle of one triangle, so you have to start with a side and then the angle and then another side, if all of those are congruent to the two sides and the included angle of another triangle, then the triangles are considered congruent. So let me give you an example here. If I were to draw a triangle like so and another triangle like so, and I said, well, this side is congruent and this angle to this side, and this angle is congruent to this side, and that side is congruent to that side. Notice that the angle is in between the two sides. This, I'll just label this. So say this is A, B, C, and this is X, Y, Z. So we'll say AB is congruent to XY, and angle B is congruent to angle Y, and BC is congruent to YZ. Then this being a side, this being an angle, and this being a side, you can use that to prove that those triangles are congruent. So let's go on and try this a little bit here. Name the included angle. Use 3 letters between the given sides. So they say JK and JL or LJ. So JK here. JK is over here. So if I highlighted JK, this is JK, and LJ there. The angle that it's been between them is this one particular angle here. And that is angle KJL. Okay. Go on trying some other sides here. KP, I'll highlight that there. And LK is right there. The angle that's in between them is angle LKP. Or I just mark that here, right there. Angle LKP. Let's go on to the next one. Angle, line LK and LP. Well, the angle in between them right there, I'll mark that. That is angle KLP as we go on. Let's go on. Next portion, try it out. Explain why you can use side angle side, SAS, and write the congruence statement. Well, here we'll start with a side, BA, right? And D are congruent, so we can say BA and DE are congruent. We can also say CA. So this is a side. Now let's look at our angle, find the angle that's in between them. Well, that's A and D. Angle A is congruent to angle D. And let's find a side. The last side, CA, is then congruent to DF. So this gives us our side, angle, side right there. And remember, we got to be careful when we write our congruent statements. Our angles need to match. So here, I'll start with A, B, C. So A, B, C. A has to match up with D. So A and D are the ones that are congruent. Then I went up to B, so I must go up to E. So it's D, E, F. Okay. On to our next example there. We want to do side, angle, side. We already are given a side. AB is congruent to BC. And notice here we have these right angle markers here. So I know that angle ABD must be congruent to angle CBD. And then here, using our, remember, our reflexive property, we can say that BD is congruent to itself, BD, from reflexive. So there we're given our side, angle, side. We have to be careful when we write our congruent statements. We want, I'll start with ABD as one triangle. Now I have to match up the angles. So A matches up with C, so triangle C, B matches up with B, and D matches up with D. So ABD must be congruent to CBD. Right, next one. It doesn't give us a angle, but remember our vertical angles. Vertical angles here are congruent, and we have an X here, so the two angles on the opposite sides must be congruent using our vertical angle theorem. So our side, angle, side, I can say AC is congruent to EC. Our angle ACB, must be congruent to angle ECD. Our side, the one with the one tick mark, BC, is also then congruent to DC. That's given us our side, angle, side. We have to be careful when we write our congruent statements. I'm going to start with ABC. ABC, triangle ABC must be congruent. Angle A matches up with angle E, so E, B matches up with D, so D, E, D, and C. Okay, let's go on to the last page. Can you side, angle, side to prove the triangles are congruent? Explain if they are congruent. Write a triangle congruent statement. So we want to see if we can find a side, angle, side. Well, they're already giving us a side, so we know SP is congruent to TP. That's one. Angle, we're given angle SPQ is congruent to angle TPQ using our markers. And then remember reflexive property, we can say PQ is congruent to PQ. So this is a big old yes. Yes, we can. And our statement will be SPQ. I'm going to match that with the angle. So S matches up with T. So TPQ. So triangle SPQ match up with triangle TPQ. This next portion, I see two sides and an angle. That works here. So I see our tick marks being used. So a side, I'll say LM is congruent to NQ. Angle is angle M is congruent to angle Q. And the last side, MN is congruent to QP for our side angle side. So this is a big ol' yes. And our triangle LMN, remember you gotta be careful, match up our angles. Triangle NQP. Let's see here. We have these two markers. This is our parallel line markers. So here we got a parallel line. We could use, remember alternate interior angles of parallel lines are congruent. So here, using alternate interior angles or alternate interior converse to prove that. So we have a side angle, and then yes, we can. We have a reflexive using our reflexive on that second side. So side angle side, we can say BC is congruent to AD. Angle BCA is congruent to angle DAC, and AC is congruent to AC is a big ol' yes. And triangle C, let's do ABC. ABC, I'll match up. A needs to match up with C. So C, A, and D are what matches up together. Remember, you have to be very careful to match up the angles. Angle A over here must match up with this angle C there. Let's looky here. We have a side and we have an angle. We can prove that this side is together. However, the thing is, this angle has to be between the two sides for us to use the side angle side theorem. And this does not have the angle in between the two sides. So this is actually a no. We cannot prove it because the angle is not an included angle. So not included angle here. Right, let's go on down to the last one. We have two sides, and using our vertical angles, we can prove that is congruent. So, and notice the sides, the angle is in between the two sides. So yes, we can do that here. So side, angle, side. I'm going to write a yes over there. We can already prove this. We can say that AC is congruent to EC. Angle ACB is congruent to angle ECD, and BC is congruent to DC. And our triangle is triangle ABC. Remember, match up the right angles. So E, D, and C. And that is all for today.